Hello friends, welcome back to my YouTube channel Canvases. So in this lecture, I am going to talk about how one could measure the strength of an acid. So there are certain parameters by which we could actually measure the strength of any acid, that is Ka or pKa. So in this lecture, I am going to discuss about what is this Ka or acid dissociation constant or pKa. So suppose in one of the acid-base reaction, hydrochloric acid is being bubbled into water. So it will instantaneously dissociate and form this hydronium ion, that is H3O plus, and chloride minus ion. Again, there is another acid that it is called the nitric acid. When it is also dissolved in water, it is also get instantly dissociated and form nitrate anion and as well as hydronium ion. So these acids this acid completely dissociates and form their corresponding ions. On the other hand, there is another acid that is called the acetic acid, that is CH3COOH. When it is dissolved in water, it gets partially dissociated. So all the molecules of the acetic acid do not convert it into acetate anion. So if the concentration of acetic acid is 0.1 molar, it has been seen that only 1% of the acid remains in dissociated form. So that's why we use these types of equilibrium sign. So that's why this acetic acid is called the weak acid. So the concept of any acid is being strong or weak is dependent upon the extent of its dissociation. So if any acid dissociated completely, it is called a strong acid. On the other hand, if any acid dissociates very less, then it is considered to be a weak acid. Now there are some parameter or some numbers which basically decides that how much strong or how much weak any acid is. So those parameters are called the acid dissociation constant Ka or pKa. So let's try to understand this acid dissociation constant mathematically. So these types of acid-base reactions are basically equilibrium-driven reactions. So if we try to write the K equilibrium of these types of reaction, where any acid is dissolved into water and their corresponding cations as well as anions are formed. So in that case, the K equilibrium constant is simply the ratio between the concentration of the product by the concentration of the reactant. So suppose we are trying to see what is the K equilibrium constant for this reaction where acetic acid has been dissolved in water. So K equilibrium is equal to the concentration of acetate anion into the concentration of hydronium anion cation divided by the concentration of water into the concentration of acetic acid. Now this concentration of water at any certain temperature, that is at 25 degrees centigrade, is always fixed, that is 55.5 molar. Now you will ask me that why this is so, why the concentration of water at 25 degrees centigrade is fixed to 55.5 molar. So that's very easy. So the density of water at 25 degrees centigrade is considered to be 1 gram per ml. So that's why we know that the molecular weight of water is 18. So in that case, 18 gram or 18 ml volume of water should be weighted around 18 gram, because the density of water at 25 degrees centigrade is 1. So if 18 ml volume of water weighted around 18 gram or exactly 18 gram, then the 1000 ml volume of water will have a weight of 1000 gram. So this 1000 gram means 1000 divided by 18 moles, that is 55.5 moles. So now 1000 ml of water at 25 degrees centigrade contain 55.5 mole. So that's why it is water has a molarity or the concentration of water at 25 degrees centigrade is 55.5 mole. So that is the reason why we are using the concentration of water at 25 degrees centigrade as 55.5 molar. So I think that it is clear to you. If you have any doubt, you can ask it in the comment section. So you could see that the concentration of water as at 25 degrees centigrade is constant. So we write the K equilibrium into water as a constant. So this constant we name it as acid constant, or we could also say acid dissociation constant. So the acid dissociation constant Ka is equal to concentration of acetate anion into concentration of H3O plus divided by concentration of acetic acid. Now what we could say from this acid dissociation constant? So if this acid dissociation constant has more value, which suggests that the more number of acetic acid has been dissociated. So more the value of this acid dissociation constant, stronger will be the acid, because larger number of the anions, dissociated anions or cations will be in the solutions. So higher the value of this acid constant, higher is the strength of an acid. Now let's try to understand this using some mathematical example. So there is an example where it is said that 1 molar of the phenol is basically a type of acid which is having an acid constant of equal to 1.26 into 10 to the power minus 10. Now the question is, what will be the pH of the medium? So we know that pH is nothing but minus logarithm of H3O plus or H plus, whatever you say. So first let's try to understand the equilibrium reaction. So phenol plus water, it will partially dissociated to phenoxide anion plus H3O plus. Now the acid dissociation constant is equal to the concentration of the phenoxide anion into the concentration of H3O plus divided by the concentration of phenol. Now I have already told you that the concentration of phenol is 1 molar, so it will be equal to 1 molar. Okay, and this Ka value is already given, that is equal to 1.26 into 10 to the power minus 10. Now at equilibrium we know that the concentration of phenoxide anion and the concentration of H3O plus are equal, and suppose it is equal to x. So now the equation is Ka is equal to x square. So x is basically the concentration of phenoxide anion or the concentration of H3O plus. So if we take the square root of x, we will get the concentration of phenoxide or the concentration of H3O plus, which is equal to 1.1 into 10 to the power minus 5. So this is the concentration of H3O plus or H plus. Now if we take the logarithm minus log of H plus, we would get the pH of the medium. So you could use this logarithm formula to get the pH of this medium. Okay. So you can say that if we have similar, as we have told you, that if we take the minus logarithm of any H plus anion that is produced, we would get the pH of the medium. So similarly, if we take the minus logarithm of Ka, that is called the pKa of any acid. So suppose any acid has an acid constant is equal to 10 to the power minus 5, then its pKa will be equal to 5. So we have to simply take the minus logarithm of that Ka value. Similarly, if any acid has a Ka that is equal to 10 to the power minus 4, then if we take the minus logarithm of that Ka, we will get the pKa of that acid, that is equal to plus 4. So you can say that we are having an acid that is in presence of water dissociated into H3O plus and A minus. So the Ka value is equal to concentration of H3O plus into the concentration of A minus divided by the concentration of the acid. So which shows that if the value of Ka is more, then the pKa value will be less. Okay, so more the value of Ka, lesser will be the value of pKa, and higher will be the acid strength. Why we are calling so? Because in the last slide I have shown you, not last slide, this slide I have shown you that more the value of the Ka, more will be the number of the dissociated ions. So more the value will be the Ka, more will be the acid constant. Now the higher the value of the Ka, as you can see, the higher the value of the Ka, lower is the pKa value. So you can see that this Ka having a value of 10 to the power minus 4 and this one has a Ka value of 10 to the power minus 5. So this is higher value of the Ka. So this Ka is greater than this Ka value, and if we take the minus logarithm of that Ka, we will get the pK that is equal to 4 in this case, and in this case we are getting 5. So higher the value of the Ka, lower is the pK value, and higher is the acid strength of the corresponding acid. Okay, so suppose we take some example. So these are the pK value of some of the acid, like acetic acid has a pK of 4.75, trifluoroacetic acid has a pK of 0, hydrochloric acid has a pK of -7. So you can see that as we are going from acetic acid to trifluoroacetic acid to HCl, the pK value is decreasing, so the acid strength is increasing as we are going from top to bottom. So that's why acetic acid is called a weak acid, trifluoroacetic acid is a strong acid, and hydrochloric acid is a very strong acid. So as you can see, in case of hydrochloric acid, the pK is less than 0, that is -7. So these acids are stronger than H+, and so that's why it is very difficult to directly measure the pK value. So there are some ways by which we can measure their pK value that I will discuss later in this chapter. So acids stronger than H+ and base stronger than OH-, it is very difficult to measure the pK value due to the leveling effect. This leveling effect I will discuss later in this chapter. So suppose we are trying to solve another problem. So there is a one question that what is the pK value of water? So in water also there is this types of equilibrium reaction going on. So this water molecule take one H+ from this water molecule and it will become hydronium ion, and this will form OH-. So the K, or the acid constant of this water molecule, is equal to concentration of H3O+ into the concentration of OH- divided by the concentration of water molecule. Now we told that the concentration of water molecule is 55.5 molar at 25 degree centigrade, and the concentration of at 25 degree centigrade, the concentration of H3O+ and OH- are all equal to 10 to the power -7. So if we put all together, we will get Ka value that is equal to 10 to the power -14 divided by 55.55, that is equal to 1.8 into 10 to the power -16. And if we take the minus logarithm of this value, we will get the pKa of water is equal to 15.7. So this is the pKa of the water. Now similar to acid, there is some way by which we could determine the strength of a base. So determining strength of a base is not as direct as acid. So for that we have to see its conjugate acid. So there is one thumb rule that we should remember, that stronger the acid, weaker is its conjugate base. So you can see there is an acid which is hydrochloric acid, which is having a pKa of -7. So hydrochloric acid is a very strong acid, and its conjugate base is Cl-. And there is another acid, that is acetic acid, which is having pKa of 4.5, and its conjugate base is acetate anion. And there is another acid that is called water, which is having a pKa of 15.7, and its conjugate base is OH-. Now if we see the pKa of these three acids, as I have told you that lower the value of the pKa, stronger is its acid strength. So you can see that HCl is much stronger acid than water, but its conjugate, so, and I have told you that stronger the acid, lower will be the weaker is its conjugate base. So HCl's conjugate base is Cl- will be much more weaker base than OH-. Okay, so it is basically reverse. The stronger the acid, weaker will be its conjugate base. But H2O is not that much of strong acid, so that's why its conjugate base hydroxide ion is very much stronger than chloride ionized. So according to the definition, the order of basicity will be OH- greater than acetate anion greater than Cl-. So the thumb rule to determine base strength is, first of all, find the conjugate acid. Suppose A minus, we want to determine the basicity of, or the strength of base of any base, that is A minus. Find the conjugate acid, that is HA. Then try to determine, see what is its pKa value, and then higher the pKa of the conjugate acid, higher will be the basicity. So more pKa value means the acid is weaker, and there the stronger will be its conjugate base. So that is the rule by which you could determine the strength of any base. So suppose we want to see the basicity of ammonia. So ammonia is a base. We will have to try to see the conjugate acid, that is ammonium plus, and ammonium plus has a pKa of 9.2. okay. Similarly, there is another base where instead of one hydrogen atom, it is replaced by methyl group. So it has a we have to see its conjugate acid. That conjugate acid is this one. So we have to see the pK, we have to compare the pK value between these two conjugate acid, and we will, if we see that the pK value of this conjugate acid, this conjugate base, so this conjugate acid is higher than this. So this conjugate acid is much weaker than this one. So that's why its corresponding conjugate base, that is methyl, this one will be higher base strength than this one. So this one is stronger base than ammonia. So by using this way, we could actually determine the basic strength of any base. So now we will see this thing. So we have I have already told you that acid base reactions are basically equilibrium driven reactions. So in equilibrium, any equilibrium driven reaction, more stable product formation is always favored. So if we try to see, or if we try to figure out what are the products that are formed in any acid base reaction, simple thing is that after the acid base reaction, we will always get weaker base and weak acid. So suppose there is a reaction that is between acetic acid and sodium hydroxide, and it will form sodium acetate and water molecule. So this sodium acetate is a weaker base than the sodium hydroxide, and water molecule is a weaker acid than acetic acid. So an acid base reaction will always produce weak acid and weak base. This is because acid base reaction is basically equilibrium driven reaction, and in any equilibrium driven reaction, more stable product formation is always favored. Okay, so you can see that there is a large difference between the pK value of this acid and this acid. So equilibrium is almost completely shifted towards the right direction. So that's why we have not written any equilibrium sign, we write like this. Okay, so that's it from this lecture, and I hope you enjoy this lecture. And if you do have any questions, please let me know in the comment section, and see you in the next lecture. Till then, bye bye.